This is a part 2 of the 3-cylinder double action wobbler compressed air motor. It's going to be some slides of the parts and the construction. This is the finished model. The back side, this side. Now this is a little jig I made up to determine some of the dimensions of the air hold, intake holes. This is a pivot point right here, and this thing will go back and forth. That would that would be the cylinder. This edge right over here would be the center of the pivot point, which would be right here in the crankshaft, and as this circle goes around, that would be where the pivot point would be. So at this position, the air holes, this would be the air hole in the cylinder, is right in the middle, and so is this one up here. I'll explode that a little bit so we can see that. This is the pivot point, and then right behind this hole you can just barely see on each side over here, one is the exhaust and one is the intake hole. And the same thing down here. Now I pivot that thing over 90 degrees, the pivot point would be right over here from the crankshaft, and now we have up here, we'll open that up a little bit. Now you can see where the air in hole is open, which would be pushing the cylinder up, the piston up rather, and then this would be the exhaust hole. And on the other side over here, this would be blocked up by the actual cylinder over the top of it. Okay, now when we go down here, the 180 degrees position, which would be over where this point is here. Now we have the air in is in the opposite hole, and the exhaust is down here. So that's the operation. This jig was made up so that I could determine some of the dimensions that I needed to be from the center of the crankshaft to this pivot point, and how far it would oscillate on each side with a certain amount of offset back here. So I just wanted to show that to you. This was made before I made that other jig that I show in the part 1 version. This is just a rough sketch before I did anything. I just sort of sketched it up and tried to determine the shape of things to be and how to connect all 3 cylinders to this point down here. I tried different ways of connecting all 3 of the connecting rods. Ended up with just overlapping them. This is the frame, this is the blank before it was shaped up, and it's all these angles were cut and it was glued together. This is the little drawing I made up that that shows the position where the holes are going to be, pretty much how the finished part is going to end up. Okay, here we are. We're boring the holes for the cradles for the cylinders. The brass cylinders will fit in this hole, and there's 2 blocks here, so we're doing 2 at one time. This is a jig that I made up, this piece of aluminum, and right here and here I'm drilling the holes that are going to be the exhaust and the intake. And this will be used for on top of the blank. Okay, I'm calling this thing the manifold, the air manifold. This is where all the air is going to be coming from. So some of these holes, like these 3 over here, are just holes in the scrap piece. They don't count for anything. This hole and this hole. And the only holes that count is right here. This is a pin that goes down into the center of this manifold frame, and this pin over here is where that goes into the pivot hole of the cylinder pivot point. And these four are going to be the holes I drill after I set this on top of the wood, drill this hole out, put the pin in, and now I can just go in here and drill these holes out. This is a picture of the thing completed. So here's there's the jig, and there's this hole over here was in this hole, and the pivot point over there was in this hole. That held the jig right in place. So all of these holes are in exactly the same location from here. Okay, these are the little cradles that ended up when I was showing the parts being bored in the lathe, and then the brass cylinders are epoxied onto the cradles. And that's just another view showing the position. Okay, these are going to be the cylinders. I'm cutting them out of a piece of aluminum, a 1/4 inch thick, roughing them out. This little diagram I made up so that I could determine the position of the intake holes. I'm going to just to blow this up a little bit. Right now this would be the piston in this downward, maximum downward position. This right over here would be the hole for intake. Right now in this position the air has come in here and pushed this thing down, piston down to here. Now when it reverses, the air will come in this hole, push the piston up to this position, and then this is where I need to have my other intake air hole. This is one of the cylinders, and you can see the 2 holes on the back side over here. These are the holes that line up with the 2 4 holes that are in the intake manifold. This rod right here is the pivot rod. This thing here is just something I just made up to do some measurements with. This gives you an idea here on the intake manifold. The air is coming in through this center, right through this hole. This hole was drilled all the way through and is plugged up here at the top. And then these things, then I was drilled here to get to the small holes, which are right here. And then these are plugs. So the airflow will flow in through here and will flow out to both of those intake holes. Let's see. And this is another view of the same thing. And some more. These are the rods, and they're press fit into these holes, and then I take them to the lathe and turn them to the right diameter. They're all turned right now, and after I did all this, I found that I was getting too much of a drag with the aluminum against the brass walls. I just couldn't get a good sliding fit without binding. And these these are the end caps where the rods come out. I started off with a wooden rod, and it was binding too much. I couldn't get a good fit, so I ended up making the ones out of steel and then bonding them into the wooden caps. The aluminum was sticking in there, so what I did, I put a steel ring around. I'm going to blow that up a little bit in here. See if I can drag that there. Okay. I turned down the aluminum and made these steel rings that go all around here. You can see this. So now I have in effect a steel piston. So that'll be a steel piston bearing on the brass cylinder instead of the aluminum. So I'm getting a lot better, smoother action this way. This is the axle, or you might say the crank. This does not rotate. This pin sticking out here is the offset pin that gives the motor its stroke. It's a 1/2 inch off center, so it results in a 1-inch stroke. When the air comes in through the frame, which this is the frame right here, I'll show that in the next slide. The air comes in here. This shaft is hollow inside. It goes through here, comes out of this hole, and goes all around this groove. So which means there's a continuous supply of air in the whole diameter of the hole. This here gives you another view. It shows the hole going through here and the hole coming out over there. This shows you when it's inserted into the frame, it only goes up to here. So the air enters in here, it comes out, it goes through the hole on the end of this, which comes over here.
I think that's Marsh's thing that's here.
And okay, now this is just another view showing you the backside. When it's pushed into the hole up to this ridge stops it, and it just stops short of here, so the air can go, get into this hole right here. When this shaft is put into the hole that's in this manifold frame, the groove will be right here, and right in this groove is the hole that leads to these things here. These are plugs in here. The next picture I'll show you a better view. Okay, there's a hole, there's a drill right from the top. It goes all the way down through here and enters down into this section down here. So the air comes in through this shaft into that grooved area and up these holes here and then into the cylinders. This is a view. These retainers and the springs over here, when I push this in, I'll raise this pin here, push that retainer up tight, the spring is under compression, and then the pin goes back in and it actually goes through the brass rod and it holds it in, so it's under tension all the time. So in effect it's pulling this piston up against this surface here, and that's where your air seal is. If that thing is too tight, it'll be too much friction and the motor won't run. This is a picture of the frame. That's the back side. The hole is plugged on the back side. This is the front side, so you can see this is where the axle enters into the framework. This is a view of the rod connection point. Let's see if I can get a little closer view. And what I did, since all the centers of all the pistons are the same center, I had to come up with devise a way to connect them to the offset pin, which is this pin right here. So what a simplified thing I did is just cutting, this is the rod end over here, and I just cut off metal, and then this one here, the rod, it's in the what do you call it, a piece right in the middle, and here's the other one. So it's something like a little sandwich, and they all just sandwich together. That's the back side of the view. When air comes in here, it's inside of this hole, comes out. These are exhaust ports out here. These two holes are where the air exhausts out of the cylinder. And this is the finished part, which we saw at the beginning of the video. So I hope this was interesting enough, and I know I did a lot of stuttering, and I hope maybe the next time I'll do a better job. But anyway, if you watch through this, thanks a lot. Appreciate it.